Good evening, Bearcats. This is A.5, which is solving equations, or in this case, we're going to mainly be talking about solving the different methods of solving quadratics. This will be in the appendix part of your textbook, and we will do classwork on that tomorrow. We're going to try to have a fun day tomorrow after our big test today. All right, so let's take a look at some of the traditional things that we've done in the past to solve quadratics. And the big one, and will continue to be a big one, is factoring. Let's do just a basic factoring together just to refresh our memory. And of course, if we factor something without a coefficient, we just got an x and an x. And then we need to multiply to -6 and add to -1. Well, multiply to -6 and add to -1, I believe we're going to use a 2 and a 3. Since we want it to be a -1, we'll have a -3 and a +2. And then if we're solving, our x values would be -2 and 3. That would be how we would solve by factoring. Now, let's take a look at one where we have a coefficient in the front. There's a little method that we learned actually a year or so ago from a kid from out of state. Came in and taught us this, showed us this method, and it seemed to have worked pretty good for solving. It's not always the best if you're graphing or factoring, but it works really well for solving. And she called it slip and slide. We're going to call it slip and divide. So we're going to take this 2 in the front, and we're going to slip it over here by the 3. And when we do, the 2 is no longer there, so we're going to start with x squared minus 5x. And that 2 we're going to multiply, so we move the 2 over here, and we're going to multiply it with the -3, so -6. We're going to factor that, and then we're going to divide things by 2 again. So we're going to slip it out and then put it back in by division. So let's go over here and just factor this basic factoring problem. So we have x and x. And of course, factoring only works if something is factorable. You know, there are some things that you're not going to be able to solve by factoring. Multiply to -6, but add to -5. I believe we're going to have a 6 and a 1, and I believe we need a -6 and a +1. So multiplied, that gives us -6. Added together, that gives us a -5. All right, now we got to be careful because we slipped it out of our problem, but now we need to put it back in, and we're going to put it back in, and we're going to divide our two values. So when we do that, we actually get x minus 3, and we get x plus 1/2. And those are our two factors. And then if we want to solve them, our x values, of course, would be 3 and -1/2. Go Bearcats. All right, let's take a look at property of square roots. All right, so now we have a square root, and the only thing we have to be really careful about a square root is, remember I told you before, when we're solving and we introduce a radical or a square root into our problem, then we're going to need to, it's kind of like being the artist, and you were the artist of that little symbol, and you're going to assign it plus or minus. You don't do that unless you're the one that wrote it into the problem. So let's take a look here. We're solving, and to get rid of a square, we're going to square root. So we just became an artist. And because we became an artist, now we have x plus 3 equals positive or negative square roots of 16. Well, we know the square root of 16 is 4, so we're going to get positive or -4. Then we need to subtract the 3, and we're going to move that in front. So right now we have x equals -3 plus or minus 4. I want my two x values because I'm solving. And my two x values then would be -3 plus 4, which is 1, and -3 minus 4, which is -7. Woohoo! All right, so make sure you don't forget to sign your artwork. Next is completing the square. I know this is one that you really enjoy. Actually, it's one that's very important, though, because it really helps when we graph things, because when we complete a square on a quadratic, it puts it in transformation or graphing form, and we can easily identify vertexes and axis of symmetry and different things like that. So it's a very helpful tool. So let's take a look and refresh our memory about completing the square. This is where we're going to move the constant to the other side. So we're going to get x squared plus 6x equals +5. No coefficient in front, so we don't have to worry about that. So we're going to go ahead and write x squared plus 6x, and we're going to put plus blank equals 5 plus blank. And what we're doing is we're going to force a number to go here that will cause this to be a perfect square. And that is how we're completing the square. So we're going to go ahead and set up for completing the square. And if you can remember from last year, we bring the x down. Since this is plus, this will be plus. If this was minus, this would be minus. And then we take half of that number, in this case 3, and we square that number. That would give us a 9, and that's what goes in our blanks. Once we do that, then we've got 14 on this side. Now we're back to just like we were before in our square root property. So we're going to square root. That means we're artists. So x plus 3 equals positive or negative square roots of 14. And then we can slip the 3 in the front by subtraction and move it right there, negative 3. And so x equals negative 3 plus or minus the square root of 14. All right. Last one tonight. Short video after that big test you had today. We're going to work on the quadratic formula. I'm going to refresh your memory about quadratic formula. Remember, quadratic formula is x equals negative b plus or minus square root b squared minus 4ac, and the entire thing is all over 2a. All right, so that's really important. You know that formula from this point forward. No formula chart, just that you flat out know it. All right, so let's take a look. Remember, in this case, we're going to label or identify everything. Our a value would be 2, our b value is 3, and our c value is negative 1. And then it's just basically a substitution problem. So we would have a negative b, or a negative 3, plus or minus the square root of, and this is all, remember, x equals, b squared, so 3 squared is 9, minus 4 times a is 2, times c is negative 1, all over 2 times a, which is 2. All right, so I need to see your substitution, and then you're going to have x equals negative 3 plus or minus the square root, and we'll figure out what that number is underneath. That number, you know what? I want you to tell me tomorrow. There's be a code word, and I'll have, just tell me when you come in. I want you to come find me, and I want you to tell me what that number underneath the radical is called. What is that number called? All right, so that'll be a little fun thing. I'll know you watched your video if you come tell me what that is. If you want to, maybe what we'll do is we'll do that on our computers tomorrow. Okay, we'll figure that out. All right, anyway, back to the problem. So we have 9 minus 4 times 2, negative 4. Make this a negative 4. So negative 4 times 2 is negative 8, but negative 8 times negative 1 is a positive 8. And we have 9 minus 8, which is 1, all over 2 times 2, which is 4. So we have x equals negative 3 plus or minus the square root of 1. Square root of 1 is 1, all over 4. Now, be really careful. Let's go ahead and finish solving this. X equals negative 3 plus 1 would be negative 2. Negative 2 over 4 would be a negative 1/2. Negative 3 minus 1 is a negative 4, and negative 4 over positive 4 is a negative 1. And there we go. Way to go, Bearcats. All right, so tomorrow I want you to come in and wait for me to tell you how to send me, we'll communicate somehow, and I want you to come in, and actually I got it figured out. Come in, open your tablet up, and go to Dino, and on your screen write the answer to that, and then we'll pull it up on the screen and take a look at it. So tell me the answer to what the name of this value underneath the radical is called when we're solving by quadratic formula. All right, have a great night. Go Bearcats.